Hi good people, Titus here for another Unreal Engine tutorial, and in this video I'll show you how to create simple HUD elements and update them via code from different blueprints. Let's not waste any time and just jump right into it. Alright, so we have our drone project that we've been working on in the last few videos. We'll just kind of reuse that for this example. So when we spawn, we'll possess the drone with a button press, and then I want to create some sort of heads-up display for the drone to maybe output some, maybe a battery life or a mini-map, maybe the speed, a few different things. So first we'll come to our content drawer and we want to import some images or things that we want to put on our heads-up display. So I have a few here. We can maybe do a battery. Let's do a mini-map. I'm going to do the mini-map overlay because I want my map to be circle, not square. And then we'll do a speedometer. So we just drag these elements in. It'll complete the import automatically, and that's great. There is one change we'll have to make since we're doing a mini map. We'll want to open that up. Under the texture section, there's an advanced that you can kind of break out. Currently, the X and Y is set to a wrap tiling mode. So when the little object gets to the edge, and if you keep going, it'll teleport over to this side. I don't want that. I want to clamp that, so I'm going to set this to actually clamp in the X and Y, and then save. We'll want to do the same thing for the overlay. The overlay is basically just, I'm going to lay this over the first image, so it's basically a circle instead of a square. So I'm going to set the X and Y tiling for that to be clamp as well. And that works great. All right, next we want to actually create our widget. We'll right click, select user interface, and then choose widget blueprint. You'll then pick user widget. I already have one made that we titled WBP_drone HUD. So I'm going to double click to actually open this up. It is blank, there's nothing in here. So let's go ahead and add in our canvas panel. And then we'll add in under common, there is an image. So we'll drag that out here. And under the brush settings in the details panel, we can select a particular image. I think we'll start with the battery icon because it's pretty easy. I'm going to check size to content. That's much too big, so I'll go to the image size, and I'm going to try maybe a 128 by 128. And I think that looks better. I want to anchor this. I'm going to pick a corner. We'll do bottom left. You'll notice that moves the anchor. I can then go back and hold Control, click that anchor point, and it moves it in. If it doesn't line up, you can go back and hold Shift, and that should place it in there nicely. Now, this is just a picture. We want to be able to actually fill up the battery. We can use a progress bar to do that. We'll want to name this battery, and we'll want to make sure that it is set to a is variable, so you want that checked. If we go back to the image of the battery, we don't want this to be a variable, so I'm going to uncheck that. But back in the battery, this works very simple. You have a percent item that you can just fill up to 1. 1 is basically full, 0 is completely empty, and obviously you have your values in between. I think it'll be nice if our battery is maybe green, so we'll swap that to a green on the fill and opacity. You can also adjust that in the style, of course. And then I also want to get rid of the gray. So under the style, you have a background and a fill. The fill is the green part, the background is the gray part. I'm going to go into the background and under tint, I'm going to set the opacity to be, the alpha or opacity to be 0. That way when we kind of adjust the percentage, it's just a green bar. All right, but let's actually make this a little bit smaller. So maybe go here, maybe right about there, and then we'll want to just move it over, kind of like so. And I think that will look just fine. So that's our little battery icon right there. And we'll control that through code, but let's add in another HUD element. This time let's search for knob, and they have a synthetic knob you can drag out. This one has a style parameter as well. You'll notice there is a large and a medium. Currently we're set for medium. If we change that to large, you'll see the image changes. We'll switch it back to medium here. So they give you some presets. Let's just stick with one. So I'll just do medium for now. I'm going to change that image though to be my speedometer. That way you see it kind of comes in here. It is compressed because the image is not square. So I can come up here and do size to content. That will adjust that for us. It is much too big though, so I'm going to do the image size and I'm going to cut that in half. So we'll do maybe a 400 by 300. I think that looks a little bit better. And then there's obviously this weird distortion going on. That's because that is the overlay, and it's currently not square anymore. So we will just go to the overlay. We'll change that to be our speedometer's arm. And you don't need to worry about adjusting the image size for the little arm because it basically inherits from the parent. So even if you reduce this, it's not going to do anything. So it's going to stay the same. But that looks pretty good. So now what we want to do is we want to set our value. You see it goes again between 0 and 1. You want to set the value to 0. And then you want to come down to your minimum value angle and you want to adjust that so the arm is reading 0, which for this happens to be 0, so that works out. Then you want to come up and adjust the value to 1. And for your maximum value angle, you want to adjust that so it ends at the end of your speedometer. So it looks like 0.8. Looks pretty good. So then you can come up here, and if you go from 0 to 1, that works just as we expect it to. All right, and we'll want to anchor this in the bottom right corner, so we will hold Shift. Whoops, sorry. We'll hold Control. There we go. And then that'll shimmy that over in the corner there. Okay, so now with that set, we can compile and save. We'll want to do a mini map as well, but let's kind of see what these look like. So let's go to our graph. And for our event construct, we'll want to set our battery to be full. So we can call the set percent. We'll just set it at 100%. This is optional. You probably don't have to do this. You could just simply set it here. But in the event you forget, this will automatically do it for you at construction. So that's just a nice, easy life hack for us. But what we really want to do is we want to add a custom event called update battery. This is how we're going to adjust this value from another blueprint. We're going to do the same code. So we're going to get a reference to our battery and do the set percentage. But we want to be able to pass in that percent value. So there's a few ways you can do that. If you just take this pin, you can drag it over here. You can also select it and come over to the inputs and hit the plus sign to add another option in here. For this option, I think I'm going to call this one our charge amount. We also need a second option called our max charge. Both of these are going to be a float. And these values are going to come from outside of this blueprint. So what we want to do is we want to take our charge amount and we want to divide that by our maximum charge. And then we want to pass that result into the percent. So why do we want to do that? Well, if you remember, for the battery, the percentage can only be a value between 0 and 1. The value that we're going to be passing from the other blueprint is going to be a value between 0 and 100. So we want to basically divide, you know, the possible maximum charge of the battery by its current charge amount, and that'll give us a nice value between 0 and 1. So that's the only reason we're doing this, basically. And this is nice to have because if you change your battery capacity, like maybe you double it or you create a mechanic in your project that allows them to get more battery and go over 100, you know, you have a way to pass that information in through automatically, so you don't have to adjust your code and all sorts of different blueprints, if that makes sense. All right, let's add in another custom event. We'll call update speedometer. And this one is going to get a reference to our synth knob, but I don't like the name, so let's go over here and we'll just rename this to speedometer or speedometer. compile, save, go back here. Now we can just get a reference to our speedometer. And this one isn't set percent, I think it's set value. So yeah, we can do set value here. And what we can do is drag that in like so. And then I'm just gonna select this and hit the plus sign to add an input. We'll call this our new speed. We'll add another input called our max player speed. And again, this is only accepts a value between 0 and 1. So we want to divide our current speed by our max speed to get that between 0 and 1 value, and then pass it in over there. So now we can compile and save. And if we come over to our drone, so this is the player drone, this is the player character. So the player character can basically press a possess key, which is something we set up in a previous video. So refer there if you want to see more on that. And it basically just gets the drone, possesses it, and it calls this custom event called enable drone. So in the actual drone blueprint, if we go to the event graph, we have that custom event called enable drone. So it checks a branch, says if create HUD is true, which is always starting off, it is true, it will create our widget blueprint drone HUD, which is what we want. And then we'll want to promote this to a variable called our heads up display for the drone, or whatever you want to name it. We'll want to pass that into our add to viewport. And then we'll set the create HUD to false. We'll set the drone enable to true. And then we'll call a function to run every 1 second on a loop called battery. In the event that this is the second time this is run, create HUD will be false, which means we're going to be setting the visibility of our heads up display to visible. And then in the event that we're calling player swap, which swaps the drone to the player, we get a reference to the player, we possess the player, we set drone enable to false, and then we have to set our heads up display to hidden so it doesn't show. Now, all that's great, doesn't really do anything besides put the heads up display on. So you see I'm the player, I can move around, I don't have the heads up display. If I push my possess button, I now have the drone. I have the heads up display, I could fly around, but the battery and the speedometer are not moving. If I go back and repossess the player, you'll see that the heads up display goes away. So that is at least working, but we're not updating the values. So we've created the heads up display, but we need to figure out how we can update the values. So we're calling this function every 1 second called battery. The function's right here. We can go to that. It simply checks if the drone's enabled. If it is, it decreases the battery charge by 1. If it isn't, it increases the battery charge by 1. So we just need to pass this information to the heads up display. So we can get our heads up display reference. We can call that custom event called update battery. And then we can execute it. We pass in our current charge amount and we need our max charge. So our battery capacity, which we're using 100, we can just pass that in here. And that basically sets that up. And then for our return the value here, we can press Control D to duplicate that. We can pass the charge amount in here when we're increasing it. And we'll also pass in the battery capacity and use our heads up display as our reference. So we can access this, this function. So this, if we compile just on its own, and this should get our battery working. So if we switch over, in the bottom left corner, I don't know if you can see it, it's probably real small, but the battery is slowly depleting. And then if I click off the character, and then we wait a few seconds, the battery will slowly increase. And then depending on if the battery reaches a certain threshold or amount, you could do something like kick the player out, you can make the drone crash, or do some sort of move to event where the drone goes to a charging station. I don't know, kind of whatever your project wants, but you can see that our battery is in fact working, which is great. But that's just the battery. Let's get the speedometer working. So we can come back into the drone, and we're going to go to the event graph. There's a few different ways we can do it. It makes more sense to probably do it on the movement side of it, but just to make this video as simple as possible, we're just going to throw it in tick. So what we'll do is we will get our heads-up display. We're going to call that update speedometer event that we created. And then when the drone's enabled, we will mess with the speedometer. So we need the new speed and we need to get the max speed. The new speed, what we can do is we can just, because we have a character movement, we can just get the velocity. And then that has a vector that we can get the length of. So we can say vector length. And then if I pass this into the new speed here, that will return at most it'll return a value between 0 and this is movement, this is walking, jumping, let's see, swimming, flying right here. So we're using the flying mode. It'll return a value between 0 and whatever your maximum fly speed is, so 600. So that'll be for that, but now we need our max speed. Now obviously you can just throw in 600, right? That works. But a better way to do it is just grab your character moment and then get max fly speed and then pass that in here. The reason that's better is because in the event that you select your character movement and you change a value over here, it'll automatically update you basically won't have to worry about everywhere you manually put in that number, if that makes sense. But just with that, we can go back here, and if I take over the drone, I can now fly around. And then as I slow down or brake, you can see the speedometer is working just fine. It's a little janky because I made it in Paint. Don't judge me. But it basically does the job. But all right, so we got a battery, we have a speedometer. I think it might be fun to close out this little tutorial with a simple mini map. I'm not gonna go over in depth of the mini map. I'm just gonna kind of show you on the heads-up display side of things. But it's really, it's not too complicated. So what we'll do is we're gonna control that through what's called a material parameter collection. So I'm gonna open that up. And you can create those if you right click, select, I think it's under material. You have material parameter collection, so right there. Currently, and you can add as many scalar or vector parameters as you want. I'm just doing 3 scalars. I'm doing one for a U and V offset, and then one for a yaw for rotation. And then we can influence these through code. So now that we have that, I have a material called m_minimap. It does 3 things. Well, mainly 3 things. The material itself is a user interface with a blend mode using masked. And that's important because it takes in a map texture, obviously. So we'll plug this in here. And then it also takes in a mask. And this is kind of where I was saying, you see the image is square. So I can plug this in here and plug the alpha in here. And now I have a rounded mini map, which is perfect. So it does 3 things. It obviously adds your image overlay. But the main things it does is it does a zoom and offset. So it'll add some scale value that you can influence. And then you need to add an offset for that scale. That's what these nodes do here. It then also adds a rotation using a texture coordinate, a custom rotator, a constant 2, which is just 0.5 to center it out. And then this is where the magic happens. This is the material parameter collection node. And you notice I'm referencing that yaw value, which right now is set to 0. We'll adjust that in a different blueprint though. And then it also moves the map based on the U and V offset, which you can think of as just X and Y on a grid. And we'll influence these through the parameter collection as well from another blueprint, and that'll move the map around. So we're rotating the map, we're moving it around, and we're zooming it in. And that's kind of the trick to make this work. Now, obviously, there's a big caveat with that, and the biggest one is you need your world center. So this is using a 0, 0, 0 kind of center. If your world is offset, obviously your center is going to be off, so it's not going to work. So if you're trying to imitate this, I'll maybe go into more in depth on a separate video for it, but just be aware that your world and your objects would have to be kind of center first, and then that's how this material kind of works. So you need to build out from there. But all right, so we'll add this in over here to the UVs. And that looks good, so we will save this. Let's go to the heads-up display. This will be a common image. And then for the brush settings, we can just search for the material name, which I called mine M_minimap. We'll size the content. That is much too small. Let's do 256 by 256. I think that'll work fine. We'll do top left, control. That looks great. And compile, save. Obviously it's not going to work, but we will see a mini map. But if I move around, it doesn't move around with me, so it's not doing anything. So what we want to do is come into the drone event graph, and we can use tick for this as well. All we're really doing is we're just going to pull off into a set scalar parameter value. I'm going to select my material parameter collection called drone, and then you basically have to add in all your various values. So we can start with the U offset first. And then the way we can get the U and V offset is that we can maybe grab the capsule component. We can get the world location. We can then split that. And then what we need to do is you need to take the X and Y and you need to divide them by some number. So what's the magic number? Well, for me it's easy because it's just one number because my map is a perfect square. But let's assume you have a rectangle, you know, something non-uniform. Let's promote this to a variable called map size X, and then we'll promote this one to a variable called map size Y. So we got to figure out the size of our map. So let me just scroll up here. We can just go to the add menu, search for a cube. And then I'm going to center this at 0, 0, 0. And then I'm going to set my movement to be maybe 500. And then I can just drag this out in 500 increments. And when I get to the edge of the map, you can see negative 4,000. If I go over here, positive 4,000. So obviously I'm a perfect square, so 4,000, negative 4,000 in the Y, and positive 4,000 in the Y. So mine's easy. I technically really only needed to have one value, but in the event that, you know, your values are different, this would be how you do it. So my map size for my X, and we'll hit compile here, is going to be 4,000. And my map size in the Y is going to be 4,000. And you don't, this is an absolute value. It's always going to be positive. It's basically how many units from center can you move in any direction before you hit the edge. So it'll always be a positive value. Yeah, so now that we have that, we'll pass in the X value into the U offset. We'll duplicate this node. And instead of the U, we'll do the V offset. And that's going to pass in the Y value. And if we just compile and save, we can see what this looks like. You can see my map is moving around nicely. And as I get to an object, you see it lines up pretty good. Here's my little ramp. That shows up pretty good. And then I have this little pillar out here. You'll notice it's not rotating though, because we haven't done the rotations. There's my little wall. And here's my little pillar. So it lines up pretty good. You'll notice the edges are kind of like meh. That's just because it's that clamp kicking in over there. That looks great. So let's get the rotation working, which of course is optional. You don't have to do that, but if you wanted it, we can just duplicate that, switch this to be our yaw, and normally you would just pass in your Z value. And for most projects, that's probably going to be your setup. But for us, we can't use the capsule components rotation because in this particular prototype, if I remember right, I'm going to select the character movement. We're actually going to look at our rotation because I think we're using the controller rotation. I can't remember. Rotation. I think we passed it. Rotation settings. So orient rotation to movement, we have unchecked. Yes, we're using the controller's desired rotation. So we cannot use any object's rotation. We have to actually right click and get control rotation. And then what we can do is split that and then pass that in here. This is still going to be an issue. I'm going to demonstrate it because it may confuse you. If we go into the drone, you can see I'm spinning around and it's going all sorts of crazy. So why is it doing that? Well, just like everything else, unfortunately, if we go to the heads-up display, not there. In the material, we're using this custom rotator to actually rotate the map. And for some reason, the rotation angle only accepts a value between 0 and 1. So this is how Unreal does things, I guess. So we need to compensate. We basically need to reduce the value of our control rotation to something between 0 and 1. So how do we do that? Same way we've been doing it with everything else. We're going to basically just divide it by the maximum potential rotation, which of a circle is going to be 360, right? Full circle is 360. Pass that in over there. Compile, save. And now if we control the drone, you can see it's a much more smooth rotation experience as I move my controller around. And this is working just great. All right, everyone, I think we'll cut it here to hopefully keep it somewhat short, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.